This first one is an example of a common kind of question, which is the strength of argument question. So the really important thing to be clear about here is this is not asking you whether you believe the British monarchy should continue to exist. So it may well be that you're, a dyed-in-the-wool Republican who believes that everything to do with the British monarchy is despicable, but that's neither here nor there. As far as this question is concerned, you have to start from a position that you are willing to be persuaded by whoever makes the most powerful argument, even if in reality you're not thus persuaded at all. So it's just about the evidence presented. And what they're looking for are detailed arguments that are directly relevant to the question being raised. That's what you're looking for. So you're going to throw out things that are just vague or things that are sort of based on emotional appeals. You're looking for factual evidence that weighs in support of whatever case they're making. So in this one, you're straight away going to be drawn to A, because you can see that it gives a proper balanced argument here, because it talks about the fact that the monarchy brings in money, explains how it brings it in through tourism, and it acknowledges that the monarchy also costs money in terms of taxation, but it says that that is outweighed by the money that's brought in. So that's a real economic argument, regardless of what else you may think about it. And then it says, well, okay, what about this money? Why does that matter? And it points out that you could use the money to improve infrastructure. So it's, again, giving detailed evidence. So A looks like a good, strong argument. B, on the other hand, you can see is much vaguer. First of all, that word some is a giveaway. Some citizens. How many are we talking about? 25 million or 2? We don't know. Some is a vague word, so that's not a good sign. And inspiration, again, is a vague word. What does that mean? What's it inspiring them to do? It might be inspiring them to commit random acts of violence, in which case, obviously, it's not a good thing. So too vague. So B, definitely we could throw out. C, monarchy costs the taxpayer money that could be used elsewhere. So you can see C and A are kind of similar because they're focusing on the economic aspects, but C is much vaguer. Costs the taxpayer money, but it doesn't recognize the fact that it might be raising money as well and balance up those two things, and could be used elsewhere. Well, could be used for what? Is it enough money to be significant? We don't know. So C is a much weaker argument than A. And D, monarchy does not deserve to continue to exist. That word deserve is an emotional word, and you're always going to be suspicious of those. Equally, if it was glorifying it and saying how wonderful it was, you're going to be suspicious of that, because you're looking for hard facts here, not feelings that people have about it. So that immediately is going to put you off that one. And similarly, no real contribution to society. What does that mean? What's a valid contribution to society? That's a bit of a vague idea. So it's very clear in that case that the only real argument with any strength at all is A, and therefore that's the right answer. Questions like this next one are essentially just algebra questions dressed up with these funny symbols. But all you've really got here is a set of simultaneous equations, and you have to basically simplify them by combining them together to solve for this term, which is the one that you don't know. So what I would tend to do is to rewrite that first sentence first of all, and just because it's easier when you're working with these things, I'm going to write D for diamond, and A for arrow, and H for heart, and just rewrite that bottom equation as that. And then think, right, what we've got to do is to reduce the number of variables, because at the moment our unknown is defined in terms of 3 variables, but we want to reduce that. And we can do that straight away, because if we look at this equation, it lets us rewrite the heart term here in terms of arrows. So we can do that and say D plus A is equal to 2 arrows plus the question mark. And then we can just move those arrows over to the other side, just subtract 2A from each side, and we get D minus A is equal to the question mark. So that hasn't solved the problem, but you can see it's reduced the number of variables, so we're headed in the right direction. But the question is, how can we figure out what d minus a is? So we look for an expression where we can find d minus a, and you can't instantly see it, but what you can hopefully see is that that top expression, which is that a is equal to d minus h, we can very easily rearrange to get d minus a. So if we bring h over to this side and the a over to that side, we get that h is equal to d minus a. And now we're in business, because if we combine that with that, we realize that d minus a is equal to h, but it's also equal to the question mark. So h is equal to the question mark, and therefore the answer to the question is that the heart is the one that will make the equation true. So we did that not using this equation at all, and right from the outset it was pretty clear that that's going to be one we wanted to avoid if possible, because it introduced an extra symbol, and we're trying to reduce the number of symbols, not introduce extra ones. So we're hoping to be able to avoid that one. But you might still think, well, how did I know to start simplifying it by using this equation rather than that one? And the answer is, well, it didn't really matter. You'll be luckier with some approaches than others, but in the end you have to just go for one. So just to reassure you that it wouldn't have mattered if we'd taken a different approach, let's again just start with the fourth equation. So we'll write that as diamond plus arrow is equal to heart plus question mark, and then think, right, well, suppose we decided to plunge in with this one, because we've got to make a quick decision, so we might have reasonably done that, and thought, right, we can replace that arrow with this definition here. So we get diamond plus diamond minus heart is equal to heart plus question mark. And then we can just tidy that up a bit and get 2 diamonds. And then if we move that arrow, that heart rather, over to that side, 2 diamonds minus 2 hearts is equal to question mark. So 2 lots of diamond minus heart. So that doesn't look immediately promising, because that's kind of a complicated expression. But if we've got an expression for diamond minus heart, then it might help us. And of course we have, because that's what that top equation is. Diamond minus heart is equal to arrow. So that's equal to 2 arrows. So now we're getting a nice simple expression, but it's not just one term, it's 2 arrows, not just one. So we need to find out what 2 arrows are, but that's easy because it tells us that here. So we therefore have that heart is also equal to 2 arrows. So putting those two things together, we therefore get the same conclusion we had before, which is that question mark is equal to h. In other words, heart is the answer. So you don't have to spend too long agonizing over which equation to start with. As I say, ignore the one that has the complicated extra term bringing in. You don't want to bring that in unless you really need to. But with the others, you usually will end up with the same answer. You're not likely to hit a dead end. You've just got to keep moving things around and rearranging. So questions like that are good to practice, because you can get quite quick at them if you just keep practicing rearranging your equations like that. This next one is a probability question. You get a lot of questions based on combining probability information, and what I tend to find is that a very useful way to put the information down in a visual form, which may help you to think your way through these things, is in the form of a tree diagram. So let's just do that and see if you find this helpful. So what we're looking for is combining the probability that Artie will scream and the probability that May will scream, and we just need either one of those things to be true, because we're interested in the probability that at least one person screams. So if we start with Artie, he is scared of 2 out of the 4 things that are hidden in the boxes. So fairly obviously there's a 50-50 chance that he'll scream or not. So we can just put that down in the form of a tree diagram and say, right, the probability is a half that he screams, and it's a half that he doesn't scream, which we'll just write like that. So So that's for Artie. And then separately, so it's an independent event because the box has been closed again, nothing's been taken out of them. So it's just independently, we can now do the same thing for May and say, right, this time she's only scared of 1 out of the 4 things. So there's obviously a 1 in 4 chance. In other words, a probability that she screams is 1/4. So we can say, right, that there's a probability of 1/4 that she screams and of 3/4 that she doesn't scream. And this is the situation had Artie already not screamed the first time. There's still a probability of 1/4 that May will scream and a probability of 3/4 that she won't. So the probability that at least one of them will scream is the sum of those 3 overall probabilities. But you can see the quick way to work that out is to just work out the probability that neither of them screams and then just subtract that from 1, because that gives you the probability that at least one of them did. And the way you combine probabilities of independent events like that is you just multiply them together. So the probability of XX, which is the probability that Artie doesn't scream and that May doesn't scream, is equal to 1/2 times 3/4, which is 3/8. So there's a 3/8 chance that neither of them screams, and that means that the probability of at least one scream, which is what the question is asking about, is 1 minus 3/8, because, you know, either somebody screams or nobody screams. There are only 2 possibilities, so the sum of the probabilities must equal 1, which comes out as 5/8. So that tells you that the correct answer is B. The probability that at least one person screams is indeed 5/8. Why not A? Well, because although it's true that if between them they're scared of the contents of 3 out of the 4 boxes, when you work it out, that must mean that the probability of at least one of them screaming is greater than 0.5. It's not a sort of direct causal thing. There's some sort of logical steps in between there, so it's a less good explanation of it. So it's not exactly wrong, but it doesn't really give a clear explanation of the reasons. C and D, on the other hand, are clearly just not right. So you can see that this mathematical business of combining probabilities is something that's worth doing, and I think a tree diagram is a very simple thing to get your head around and practice. And again, if you just plunge straight in and do one when you get this combining probabilities thing, it may well be the quickest way of doing questions like this. So then on to everybody's favourite, the Venn diagram question. If you haven't thought about these for a while, then this is something that you need to refresh on, because you get a lot of these. So in this question, the key bits of information that we've got to start with are these, and these are defining what we call subsets. Okay, so this is saying whales are mammals. In other words, all whales are mammals. So the set of whales is a subset of the set of mammals, and that means the area corresponding to the whales has to be completely contained within the area that corresponds to mammals. But also, all whales can swim, and therefore again that same area corresponding to whales has to be completely contained within another area, which is the set of animals that can swim. And you can see that A has that possibility, because the circle here, that could correspond to the whales, and they're completely contained within this oval area, but they're also completely contained within that circular area. So that looks like a candidate. And if you look at B, C, and D, you'll see that none of those is possible, because in B, for example, the circle here is completely contained within the bigger circle, but it's not completely contained within the oval. So it can't, therefore, if B were the diagram, it couldn't be true both that all whales are mammals and that all whales can swim. And the same with C and D. So in fact, A is the only possibility. So having worked that out, you could immediately tick that one and move on. But we can just go through that to make absolutely sure, given that we have got time to do that. So if this is the whales, we're saying it's completely contained within these two sets, but it's also telling us that not all animals that can swim are mammals. So if the oval represents the animals that can swim and the big circle represents the mammals, you can see that that describes the whole thing, because all whales can swim, so they're all contained within that oval area, but there are some in this region here on the outside which can swim but which are not within the big circle, so they can swim but they're not mammals. On the other hand, all whales are within the big circle, so all whales are mammals, so that fits. But that was one that you could get very quickly by spotting that the whales have to be a subset of two different big sets, and therefore the whale space has to be fully contained within two separate other spaces, and that was only true for A in that one. This next one is essentially a verbal reasoning question, but it's very different from that section because instead of a long paragraph, you've got this very short sentence, but it's very technical. And the idea is that this time you really do have to make sure you've understood fully what it's saying and use that detailed understanding to tease out the answer to the question. So before we get into that, the thing that's incredibly important to notice here is this word cannot. You really had to read this question carefully and make sure you recognize that you were looking here for the statements which were not true or not necessarily true based on the passage. If you misread that, then obviously you'd get exactly the wrong answer. So that would be bad. So make sure you read the question carefully. So which cannot be concluded from the information provided. Okay, so let's get stuck in. If a patient is taking warfarin and clarithromycin, the rate of elimination of warfarin will be increased. So let's have a look at the text to see what we can figure out about that. So it tells us that warfarin is metabolized by this enzyme, cytochrome P450, to inactive metabolites, and that's the only significant route for removing it, because it says it's degraded or eliminated from the blood almost entirely by this process. And having been metabolized, the metabolites are then excreted in the urine. Okay, so we would expect that anything which interferes with the activity of cytochrome P450, that the enzyme, will affect the rate of elimination in the urine for that reason. However, the word we have here is affect. Okay, clarithromycin affects the function of enzyme cytochrome P450, but that doesn't necessarily mean it makes it worse. There are lots of activating substances in biology which increase the activities of enzymes and things. So we can't assume that clarithromycin decreases the activity of cytochrome P450 and therefore decreases the rate of formation of these metabolites and therefore decreases the rate at which they're eliminated. We can't assume that because it's possible that it would have increased it. So that one we can't conclude. So that appears to be the right answer straight away. So if you're in a rush, you could say, right, well, that seems not to be true. But let's just check, therefore, that the other ones are all true, which you probably wouldn't do in the actual thing because you wouldn't have time. But again, it's good training when you're doing these practice ones to spot the kinds of traps they lay for you. So B says there will be a higher concentration of inactive metabolites than warfarin in the urine. Well, it tells us that warfarin is eliminated from the blood only really by this process of metabolization. So in other words, warfarin itself doesn't end up in the urine. It's only these metabolites of it that end up in the urine. So B seems like it will be true, that there will be more of these inactive metabolites than warfarin because the warfarin doesn't get into the urine. C cytochrome P450 plays a key role in the elimination of warfarin. Well, that's clearly true. Okay, warfarin is eliminated only by forming these metabolites, which are then excreted in the urine, and cytochrome P450 is the thing that causes these metabolites to form. So yeah, that's definitely a key role. Extra care may need to be taken when a new antibiotic is prescribed to an individual who takes warfarin. Well, yeah, because it tells us that warfarin is very important in regulating blood clotting, and preventing blood from clotting when it shouldn't. And so if you took an antibiotic such as clarithromycin, it's going to either mean that your blood will be more likely to clot when you don't want it to, with a risk of causing thrombosis or something bad like that, or it means that it might not clot when you need it to, when you cut yourself or whatever, and both of those things could be very bad. So yeah, you need to be very careful if to make sure that the patient is aware of the problems of taking those antibiotics, or indeed better, find a different antibiotic that doesn't matter. So yeah, that one is true. So A was definitely the right answer, which we got straight away. So you can see that this decision-making section is a bit different than some of the others in that you get a whole range of very different kinds of questions in this section. So there's a lot of practice that needs to be done here, because there's different skills, obviously very different skills in a Venn diagram question than in a sort of verbal reasoning question like the last one. So there's a lot of practicing that needs to be done to get really good at this. And it is still partly about building up your speed, as it is throughout this whole UCAT test. But here it is also about the fact that your thinking has to be really clear and precise. So they give you sort of more time for each individual question in this section, not masses, but more than you have in other sections. And that means that the balance is a little bit different. You can't rush headlong at the questions quite so much. They're going to take some serious thinking. And it's important therefore to do as many as possible so that you can get a feeling for what that balance is, for how long you can be spending on doing them. But as you'll have realized from these examples, there are a lot of things that really take thinking through. You can't just instantly pick up the information from what's presented in front of you. You have to process it quite a lot to get to the answers. So lots of practice to get that balance between speed and detail correct. And that processing, I mean, this varies with different people, but certainly for me, and I think for lots of people, you can't do it all in your head. You have to scribble things down to make sure that your thinking is clear. So practice, scribbling stuff on a bit of paper. You would have a whiteboard in the actual exam, and also this comes up much more in the calculation section, but sometimes applies here too. Make sure that you're good with the on-screen calculator. You can save a huge amount of time if you're quick with using that calculator. So that's again something to make sure you practice.